It's time for another episode of Pre-Calc in Pajamas. Hi everyone. I hope you liked vectors last week, because that's what we're doing until the end of all of this. So last week we focused on finding magnitude and direction of vectors, and this week we're going to focus on adding, subtracting, multiplying, and then finding the angle in between two vectors. So for this entire video, u and v, we're just going to deal with vector u and vector v. And I'm going to really make a good u and make a good v so that you can tell that there's a difference. So we're going to say that vector u, I'll put like the little foot thing, is 3, 4. And we're going to say that vector v is 5, negative 1. Vector u, vector v. For the rest of this episode, I guess I'll call it an episode, this is u, this is v. I made my u a little bit curly at the end so that we don't confuse it. So let's take an example of multiplying one of these by just a scalar, just a number. You're going to do exactly what you think you would need to do. So if this is vector u, I want to know what 2u would be. So I can ask you, thank you, I can ask you, what's 2u? And literally, all you do is 2 times 3, 2 times 4, and you get 6, 8. That's it. It really, there's nothing more to it. Now, what if it was a negative? So what if I wanted to find negative 3 times vector v? Well, all I do is I take negative 3, and I multiply it by 5. I multiply it by negative 1. I'm careful with my signs. I know that 15 is negative and 3 is positive, and that's that. So that's just multiplying it by a scalar. You will see addition and subtraction problems where I'm like, oh, what's 2u plus v? And you'll multiply the 2u and then add it to the v. So what does even adding look like? I think you'll be happy because adding and subtracting are pretty cake. All you do, and let me show you what this would look like. I think that would help. So if I had 2, 3, 4, 1, 2, 3, 4, let's draw vector 3, 4. So this is vector u. So when I'm adding it, what I'm doing is I'm taking this vector here, 5, negative 1, and I'm putting it on top. So that would be 5. So I'm going to go over 5, down 1. And as you can see, that would be 5, negative 1. So I'm just putting them on the end of each other, basically. And what we're solving for is this dotted vector. That's what we're getting at. That's why this works. So u plus v is going to be the same thing as v plus u. And we're going to get, we can actually just look at it and figure it out, right? So it looks like 1, 2, 3, 4, 5, 6, 7, 8. Did I draw it right? 1, 2, 3, 4, 5, 6, 8. So we are over 8, and we're up 1, 2, 3. This would be so much easier if I had you guys in class, but so according to our picture, it's 8, 3. And if we look at our coordinates, it's going to make complete sense, right? Because 3 plus 5 is 8, and 4 plus negative 1 is, whoop, there's the 3, and that's it. So when you add vectors, all you're doing is adding your x's, boom, x. Adding your y's, boom, done. That's it. That's it. That's the only thing you're doing. So now, what we do is when we're subtracting, it's essentially adding the negative. So the negative just points at the opposite way, blah, blah, blah. I'm not going to show you the picture of that. I'm just going to show you the nice and quick way, because probably the picture confused most of you, and I'm so sorry. Subtraction. So we're going to do vector u minus vector v. And if I look at it, 3 minus 5 is negative 2. And 4 minus negative 1, be careful because it's minus negative 1, it's 5, that's it. Ding, 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 done. That's it. That's it. So I didn't have this in my notes, but I'm just going to do one just because I feel like it needs to be done. Let's do that 2u plus v. Because you do have questions like this. So the first thing I'm going to do is I'm going to take this, multiply it by 2. That's going to give me 6, 8. And then I'm just kind of rewriting what I have for v. So this is the 2u, this is the v, and then to get my resultant, that's what we're going to call it. We call, when we add or subtract 2 vectors or multiply, we call that the resultant. 6 and 5 is 11, and 8 and negative 1 gives me 7. That's it, all done. So that's adding and subtracting, no big deal. I don't know why my watch vibrated, but I'll deal with that later. So that's adding and subtracting. You'll like adding and subtracting. I can't foresee any of you saying, I hate this. Who knows? Multiplying is where things get a little bit funky. It's still very doable, but the most important thing about multiplying vectors is realizing that you're not going to get another vector. You're going to get a scalar. And remember, a scalar is just, it talks about one direction. It's just one number, one direction, and it's essentially the magnitude, but it doesn't have direction. And the reason for that is when I'm multiplying a vector with another vector, it's almost impossible to tell what direction it's going to go in. So we just focus on the magnitude, and that's that. So I'm going to write down the formula for you. It might be a little confusing looking, but then we're going to do some examples, and I think that will help. So vector u times vector v, this is called the dot product. So we're going to do the x-coordinate for u times the x-coordinate of v plus the y-coordinate of u times the y-coordinate of v. So I'm going to leave that up there, make sure that, the multiple screens in the background are not blocking it. Yeah, take a picture, do what you want. Write this down in your notebook if you even have that and it's not stuck at school. So that's a formula we're going to use. You get a number. And please be careful because signs do really, really matter. So if it's the -1, keep it the -1. That's going to make its mini product a negative number, and that really is okay. So if we're looking at this, what I do is I go, all right, so let me multiply my x-coordinates. So 3 times 5, 15. And then I go to my y-coordinates. 4 times -1 is -4. And then it's just addition, guys. Well, technically subtraction, but it's just this part right here, 15 plus -4. My answer is 11. That's it. That's multiplying vectors. You just get a number. That's it. It's easy peasy. Okay, so the time that you would use multiplying vectors is when I want to find the angle between two vectors. Like if the tails of the two vectors were together, and I don't know why I didn't just do it the other way, but like if the vectors were like this, you know, we want to find the theta in between. It'd probably make more sense to draw it for you rather than do some weird arm thing like I just did. So yeah, let me draw the two vectors. 2, 3, 4, 5. 1, 2, 3, 4. And then 5, -1. So here is vector u, here's vector v. And what we want to do is we want to find the angle between them. We want to find that theta. That's not a 0 with a line through it, that's theta. Hello, theta. Good to see you again. So that's what this is. And there is a formula to do it, and I'm going to write that for you right now. It involves using cosine, technically inverse, but we'll get there. So finding the angle between two vectors, it does require a certain amount of steps, but that's why we're using u and v, so we already have half of it done for us. So when we find the angle between two vectors, I want to do the dot product of the two vectors over magnitude of u times magnitude of v. This is the formula. Write down the formula. If you take notes. If you don't, that's sad. But here's your formula. Great. So like I said, half of it's already done, right? Because we know what the top is. We know that's 11. We just found out it's 11. So let me write that somewhere so we don't forget, because I want to spend the next amount of time refreshing your memory on how to do magnitude. Remember, magnitude is just Pythagorean theorem. That's it, right? And I was fortunate enough to make one of these Pythagorean triple. So to find the magnitude of u, just to refresh your memory on what u is, we're going to do 3 squared plus 4 squared. That gives us 25, and then we have to take the square root. So the magnitude of u is just 5. 3 squared plus 4 squared is 25. Take the square root of 25, get 5. Boom, done. It's Pythagorean triple. I love my Pythagorean triples. 3, 4, 5, 5, 12, 13. They're your best friends. I honestly hope they're not, but they're really important in math. And then next what we're going to do is we're going to find the magnitude of vector v. Be careful with that negative, because when you square a negative, it becomes a positive. Cool. Maybe if I can take the cap off of this, it would be more easy to write with. Okay, so I'm going to do 25 squared, so 5 squared plus -1 squared. So 5 squared is 25. 25 plus 1, because 1 squared is 1, gives me 26. As you can see step by step, now I'm going to have to take the square root. And I get 5.099, which I'm going to round to 5.1, just because it's nicer and neater. I didn't round at the 5. That's too much. But rounding at 5.1 is A-okay. So we know that the magnitude of u, that's a sad looking u, that looks like an A. We know that the magnitude of u is 5, and we know that the magnitude of v is 5.1-ish. So I'm going to put in a little box the information that we have, and then we're going to look at our formula again. Remember, our formula is the cosine of theta equals the dot product over the magnitudes. Cool. So this is our formula, and now we're going to plug and chug. I know that my numerator is just 11. I know that my magnitude of u is 5. And we're going to multiply it by the magnitude of v, which is 5.1. And that's going to give me 11 over 25.5. So now we're here, right? We're basically at cosine of theta is 11 over 25.5. And at this point, this is where most of you are going to be like, I don't know what to do next. But surprise, you actually do know what to do next. Let's get a value for this right side here. So if I typed in my calculator 11 divided by 25.5, I'm going to get roughly, what was it? 4.431, right? We're here. And now what we have to do is take the inverse cosine of that. Because we're solving for an angle. It makes sense. That's what the inverse cosine does. It gives us the angle. So I'm going to erase all that work. We're going to do the inverse cosine. God bless you. 0.431. And that's going to give us our angle of 64.4 degrees. Ta-da! That's it. That's all that you have to do this week. I know I kind of soared through that. I thought it was going to take a lot longer. But let's take a short video when we can. If you guys have questions, please reach out to me. I've been doing a little bit more Google Meets a week, which really does brighten my entire day when I get to see you guys. So please let me know if you need anything. There are calculators online that kind of help you figure out this stuff too. I'm not against you using them because I know that had you all been able to bring home graphing calculators, you would be using them. So if you found an online calculator with all the functions that you need, feel free to use it. I really am okay with that. I will talk to you guys next week. Bye!